Friesen. Good afternoon, ladies and gentlemen. My name is Abby Angel, and I am the president of Friends of CIHR. It's a great pleasure for me to welcome all of you to the 2015 Friesen International Prize Public Forum. Friends of CIHR was established in the year 2000 to advance the goals and ideals of CIHR, to establish partnerships in the community and thereby promote a better appreciation of the importance of health research in society, to increase the level of discourse and understanding of health issues broadly, and to support the development of young trainees as future scientists. The 2005 Henry Friesen International Award was established then by Friends of CIHR to recognize an iconic figure in Canadian health research and health policy development who was instrumental in the creation of the Canadian Institutes of Health Research. We are delighted that Dr. Friesen is here with us today as we once again recognize his seminal contribution to Canadian science. Welcome, Dr. Friesen. Thank you for being here. The Friesen Prize itself is awarded to individuals at an international level who embody Dr. Friesen's vision and scientific achievements. Nominations are gathered annually from many sources, including universities, health research institutes, and senior policy centers across the country. The prize winner must have impeccable scientific and academic qualifications and must be an effective communicator willing to share his or her experiences and vision through public lectures, with video and radio interviews, together with visiting lectureships. Congratulations, Sir Paul Nurse, on receiving this award and being with us today. I'd like to point out that there are a variety of responsibilities that the Friesen Prize winner accepts in accepting the award. Apart from the major lecture, he or she is involved in a variety of activities and extends the impact of Friends of CIHR and the Friesen Prize nationally. And we're delighted that Sir Paul has accepted the additional burden, not so much burden, activity of going to McGill University, hosted by Rosie Goldstein and others, to continue the process in delivering a lecture. Sir Paul has also accepted to go west in May to visit Calgary and Alberta, University of Alberta in Edmonton. Thank you, sir, for doing that. The Friesen Laureate has also committed to extend the impact of the prize by contributing an essay which is printed, which immortalizes the words for years to come. And I'm delighted to say that this is hot off the publication, Dr. Harvey Feinberg and Lapchi Choi, and copies are available on the back for those interested. And please take these as complimentary gifts celebrating the 10th anniversary. So this is one of the other outputs of the Friesen Prize program. The purpose of today is, of course, to hear from the prize winner, and so I will now complete my remarks and look forward to other welcoming remarks by guests. Thank you very much.
Thanks, Abby. There are more welcoming comments, and they'll come to you in a moment. And in fact, from someone who I feel like I have to say thank you to. University of Ottawa has almost become second home to ideas. This year, the Congress was here, the Learned Societies, it used to be called. Ideas had a major, or not major, but a minor presence there with a couple of events. And there have been other symposiums and panels that I've hosted literally on the campus more downtown than here over the last year. Here to welcome you officially from the University of Ottawa is Dr. Niemer, I'm sorry, it's not French, it is English, who will be here to welcome you from the University of Ottawa. Thank you.
Monsieur le ministre Meridian, cher Henreid, distingués invités, chers collègues, chers étudiants, vous êtes nombreux dans la salle, vous êtes bienvenus ici à la 10e édition donc, du prix Henry Friesen. distinguished guests and dear colleagues, it's a great pleasure for the University of Ottawa to continue to be a partner with the Henry Friesen Award, and I would like to thank Dr. Angel for the remarkable work that he does to make sure that every year is actually more successful than the previous year. The leadership of the University of Ottawa had the distinct pleasure of having a personal connection with Dr. Friesen, a remarkable scientist and a remarkable academic leader in our country. President Rock was the Minister of Health when CIHR was born, and he was a great supporter of the initiative. And I had the privilege at the time of being on council of the Medical Research Council and working closely with Dr. Friesen. Those years were extraordinary. I was a young researcher and prof, and I remember telling Dr. Friesen later that I learned so much, I really felt like I had aged. But CIHR was a remarkable initiative. It's remarkable for our country, and the University of Ottawa is very happy to continue to be a supporter of Friends of CIHR and of the Henry Friesen Prize. So thank you very much.
Thank you, Dr. Niemer. We are in the federal capital, but here to bring greetings from the Government of Ontario is the Minister for Research and Information in Ontario, Dr. Meridian.
It's a great pleasure, ladies and gentlemen, to be here this morning, and it's an honor to join so many distinguished guests at this year's Friesen International Prize program. This esteemed award was established a decade ago to recognize Dr. Henry Friesen as one of Canada's most prominent scientists with over 50 years of incredible achievements and contributions to science in our country and around the globe. That same year, the Friends of Canadian Institute of Health Research awarded Dr. Friesen with the Distinguished Service Award. The award recognized, I quote, his unique accomplishments in health research and his qualities as dedicated servant of humankind. To be a servant of humankind, ladies and gentlemen, I believe is the greatest achievement to help others in need, to save lives, to give people hope. Everyone here today should be proud of the ways that you serve, spending years in lab with patience, persistence, and the will to succeed. That noble aim of discovery is reflected in the work of this year's Friesen International Prize recipient. Sir Paul Nurse identified how the eukaryotic cell cycle is controlled. This fundamental discovery may, in the long term, open new possibilities for cancer treatment. This is a landmark discovery, and for his outstanding work, Sir Paul has received awards around the globe, including a Gardiner International Award and indeed a joint Nobel Prize in 2001. Sir Paul's contributions reach around the world, offering people and their families a new hope for diagnosis and treatment. He is a pioneer scientist, a science advocate, and a science policy maker. Sir Paul has made a major impact through his sustained excellence over a distinguished career. He is an exceptional innovator and a true giant in the fields of human genetics. Ladies and gentlemen, we are all inspired by Sir Paul's work. He is also a role model for researchers across Canada and especially here in Ontario as we continue to lead the country with remarkable breakthroughs in many areas, including regenerative medicine, cancer, and stem cell research that benefits Ontarians and the people around the globe. with a remarkable record of innovative firsts, from helping diabetics with the invention of insulin to keeping people's heart beating with the pacemaker. And that fine tradition of research and innovation first continues in our province of Ontario. In fact, just last month, we learned that researchers at the University of Ottawa and the Ottawa Hospital discovered that Duchenne muscular dystrophy is a stem cell disease. This astounding breakthrough is a big step toward better treatment and the quality of life for people with this kind of disease. And it brings much needed hope for their families and loved ones. Ontario is committed to investing in research to help ensure that innovative ideas become a reality. A couple of years ago, one of my colleagues asked me the question. He said, Reza, we have been investing enormously and significantly in research and innovation. What do we get in return? I paused for a second and I responded by saying that, look, if 25 years ago a woman had a breast cancer, or if a man had a prostate cancer, that was more or less a death sentence. Everybody knew that that person is going to die in a few months. But today, these diseases are treatable if they are diagnosed early in life. People don't die of breast cancer or prostate cancer unnecessarily. So after a few seconds, he said, now I know we have invested in the proper projects. And it is true. But this kind of research and innovation, of course, brings much needed hope for everyone, for families, for loved ones, for patients, not only in our province, in our country, but for 7 billion people on this bigger country of us, which is called planet Earth. Our province of Ontario is committed to investing in research to help ensure that innovative ideas becomes reality to help people. That's why we support research through programs such as Ontario Research Fund and Early Researchers Awards, and institutions such as the Ontario Genomics Institute, Ontario Institute for Cancer Research, Ontario Brain Institute, and Ontario Institute for Regenerative Medicine. The Ministry of Research and Innovation is working diligently to ensure our province remains at the forefront of research and discovery. And we are committed to fostering collaboration between researchers, academia, health and healthcare practitioners, entrepreneurs, venture capitalists, and businesses to get these discoveries out of the labs to the patient's bedside. To everyone here at the Friends of Canadian Institute of Health Research, thank you for supporting, celebrating, and promoting scientific excellence. This prize brings the world's best researchers to Canada to share ideas and work with scientists across our country. It connects some of the best scientific minds of our generation and provides inspiration to the next generation. Again, congratulations to Sir Paul Nurse. This prize is well deserved. Ladies and gentlemen, we will work together and build on our common goal to create a healthier world. Thank you very much. Merci beaucoup.
Merci beaucoup. It's lovely to see you again, Paul. Henreid, my greatest honor to be here with you. And ladies and gentlemen, colleagues, you know it's a great privilege for me to introduce and welcome Sir Paul Nurse. You may not know by his own words that he likened the aesthetics of scientific understanding to reading a great poem. And at great risk, we talked about risk this morning, at great risk I offer a poem. It's not a great poem, but it's about a great person as your introduction and welcome. Sir Paul Nurse, a wildly worthy recipient of the prestigious 10th Annual Henry G. Friesen Prize, is a brilliant, generous, humble, and reflective soul which should come to us as no real surprise. Sir Nurse, a journey well accounted here and there in biographies and in the best of science, has shown throughout his career a most adaptable learning spirit and thoughtful self-reliance. Paul Nurse showed one key property of mind, shown early in his staggered and intriguing course, on walks home from school, on mountain treks, his curiosity genes expressed like Scottish gorse. Thus Sir Paul, despite his stated curse of ignorance in languages not English, then known as foreign, was able to easily complete a Birmingham baccalaureate, not impeded by, quote, poor memory, unquote, thorn. As an undergraduate, Paul Nurse was blessed with biologist Professor Jinks, but more so by Anne. She would become his wife of many years, filling out his viewpoints to a broader life, a better man. Systems of ecology struck chords in Sir Paul's being. Developmental biology proffered by Jack Cohen. Alternative ways of thinking, Thomas Kuhn-like perspectives, cell cycle interests, seeds were then sown. From thence to Tony Sims at University of East Anglia, where Sir Paul pursued the advanced degree. On fungus Candida utilis, he weathered the throes of metabolism discovery and did receive the PhD. Postgraduate studies, reproduction, the vital cell cycle at Edinburgh and Murdoch-Mitchison came. To a certain extent, the genetical work on budding yeast by Leland Hartwell was there to blame. With Swiss augmentation by Urs Leupold in genetics of the fission of yeast cell cycles, now fully embraced, academic freedom, complete support, selfless mentoring by Murdoch, any directional doubts erased. The fungal gene, CDC2, rate-limited mitosis and also conducted the orchestra for S-phase transitions. Observations born of ambiguities in experiments designed to understand G2 cell cycle progressions. From there, the stories had emerged, and Sir Paul would be sought by many an intellectual scout. Edinburgh to Sussex to Lincoln's Inn Fields, phosphorylation of CD2 kinase, also human, the route. Oxford called. Sir Paul saw himself president of the UK Genetical Society and then to the ICRF once more. This stage of investigation reinforced a friendship with Tim Hunt, biochemist, a partnership of lore. Thoughts of cell cycle regulation never faded, but dialogue between scientists and the public surged. And contemporaneously, with his guidance, the ICRF and the CRC into the Cancer Research UK merged. Sir Paul Nurse has been honored far and wide, from Nobel to learned societies around the world. Perhaps most crucially, his connection between the power of rigorous science and society is unfurled. Today, he joins us to share views on what he has learned about harnessing inquiry for society's good. Please welcome Sir Paul with a rousing cheer. Standing up for stimulation, I think we all rightly should.
Well, well. Can you hear me? Is that good? That easily was the most extraordinary introduction I have ever had, and I thank you very much for it. Please, can I have a copy? Ladies and gentlemen, it is an honour and a pleasure to be speaking to you here this afternoon, and to be receiving the 2015 International Friesen Prize. It's a particular pleasure for me because of the enormous regard I have for Henry Friesen. He is, as you know, a giant of Canadian science who contributed greatly not only to science, to medicine, but also more generally to Canada over many, many years. I've known Henry for 3 decades, I think, and it's an honour for me to be associated with his name through this prize. I want to talk today about how creative discovery research enhances our culture and our civilization, but also brings about advances for society more generally through improving our health, our quality of life, through helping solve the world's biggest problems, through supporting sustainability. Science influences nearly everything that we do at home or at work. It's essential to drive our economies, to help us tackle global problems such as feeding the world, ensuring we have sufficient energy. And it is my view that science can play an even greater role for us all in the future, improving our lives, improving our economies. So let me begin by asking a question. What is special about science that makes it so good at generating reliable knowledge about the natural world? Science is good at this quite simply because of the way that science is done. Good science is a high calling. It's based on honesty. It's based on openness. I agree with Sir Humphrey Davy, 19th century chemist, inventor of the miner's safety lamp. He said, "To me, there never has been a higher source of honour or distinction than that connected with advances in science. The bedrock from which all science flows is reproducible observation and experiment. This means that ultimately what is observed, the data, trumps all, even, I'm afraid, the most beautiful idea. Scientists need to take account of all observations, all experiments, not just cherry-pick data that happens to support their own ideas, their own theories. Scientific issues are settled by the overall strength of evidence. Often a particular idea drives what observations scientists will make. But sometimes, of course, scientists make observations without a precise idea in mind. More whimsically, I call this following where nature leads you. You cannot always control nature. You should sometimes follow nature. But experiments and observations, of course, are not enough alone. It is really the ability to prove that something is not true which is at the centre of science. This distinguishes it from beliefs more based on ideology or religion, which place much greater emphasis on faith, on tradition, on opinion. Scientists, however, have to come up with ideas that can be tested and then can be refuted. And generating good ideas is difficult. It requires in-depth knowledge of the field, complemented by peripheral understanding of related areas of science. Critical is a creative approach to come up with novel ideas with strong explanatory power. Once an idea or hypothesis has been generated, then experiments have to be devised to test it further. If the result of the experiment does not support that idea, then it is rejected or modified and tested again. If the results of the experiments support the idea, then it becomes increasingly more acceptable as an explanation of the natural phenomenon. This is really how much of science works. But implicit in this approach is, of course, that scientific knowledge evolves. Early on in a scientific study, knowledge is often tentative. It's only after repeated testing that it becomes increasingly secure. It is this process that makes science reliable, but it also means that science can take time. And this leads to problems when scientists are called upon to give advice on issues when that science is not yet complete. We see it every day in the newspapers, whether a medical procedure is safe or whether eating certain foods are good or bad for you. The public sometimes want clear and simple answers that are not always possible. People need to understand the tentative nature of science in certain circumstances. And we have to start in our schools to demonstrate that. Science is often taught in schools based on the great ideas that have successfully undergone much testing. I mean, quite appropriately so. Those are the ideas of Newton, of Darwin, of Einstein. And so we tend to think that all science is equally secure, written in stone. But this may not be the case, particularly, as I've said, at early stage in research, where knowledge is more tentative. And it's this view of science that I think requires greater emphasis at school. Sometimes science is very secure, sometimes it is less secure and more tentative. There is, of course, a certain humility that goes with that position that we need to have as well. It is not always possible to achieve complete certainty on complex scientific problems, yet sometimes we still have to take action. And in these circumstances, society needs to turn to expert scientists for their consensus view. That's the safest thing that we can do. We don't listen to mavericks and those that are peddling extreme positions, which are unlikely to be helpful, and sometimes we hear far too much about. There are personal qualities which are important for science, for scientists. Scientists need to be creative, they need to be skeptical, they need to be honest and transparent, and in my view, they need to be courteous in scientific dispute. It's very important that you argue and disagree. It's fine to say that somebody's idea is stupid. It is not fine to say they are stupid. Courteous debate helps. Humility and self-doubt help as well. The 17th century courtier and philosopher Francis Bacon said, "If a man will begin with certainties, he shall end in doubts. But if he will be content to begin with doubts, he shall end in certainties." Put all of this together, and you have a process which can offer extraordinary insights into the natural world, and that is what science delivers. But the work of science can also require courage, as it sometimes strikes at the heart of accepted thinking. Challenging established opinion can be part of science, and it can bring about revolutionary changes, and these can be very unsettling for society. Displacing the Earth from the centre of the universe, first to an orbit round the Sun, then to the arm of a galaxy within an infinity of galaxies, had a profound effect on the position of humankind. Evolution had the same dramatic effect, moving us from being specially created and separate from the rest of life to being related to every living organism on the planet. Charles Darwin recognized this in his Descent of Man, published a few years after The Origin of Species. He said, "Man, with all his qualities, with sympathy, with benevolence, with his godlike intellect, with all these exalted powers, man still bears in his bodily frame the indelible stamp of his lowly origin." I imagine Darwin wandering around a museum of natural history, observing the skeletons of our near relatives. These ideas about the Earth and about the origins of humankind were once unthinkable, once heretical, but are now fully accepted by all those who respect knowledge and the power of reason. So science can be a truly revolutionary process, and we have to be ready for what it might reveal. Some scientific issues are of crucial significance to society, but can only be properly addressed if we have a healthy relationship between science and the public. Scientists need to identify such issues early to encourage open debate about the implications and consequences of scientific or technological advances. Such debates will sometimes be difficult, but they must take place. This is essential if we are to have a society that is comfortable with science and therefore that can reap the benefits that science can bring. And science can bring us great, practical, everyday benefits. It has always been a useful art, generating knowledge that, when properly used, leads to applications through technologies, through engineering, through applications, all for the public good. At the birth of modern science, Francis Bacon argued that scientific knowledge gives us the power to relieve man's estate. Robert Hooke of the Royal Society, also in the 17th century, emphasized how scientific discoveries, I like this quote, on motion, light, gravity, magnetism, and the heavens, all things of interest to scientists in the mid-17th century, would improve shipping, watches, optics, and engines for trade and carriage, also all applications of interest to the 17th century person. Today, we face other problems, some of them major. Food security, climate change, global health, making economies sustainable. All of these need science. It is critical, indeed, for our democracy to have mature discussions about these issues. But these debates can sometimes be threatened by a misinformed sense of balance and inappropriate headlines in the media, which can give credence to views not supported by science and by those who distort the science with their ideology, their politics, or even their religion. From the very beginning of science, there have always been such threats. When Galileo argued that the Earth orbited the sun, the Inquisition did not argue back with science. They simply showed him the instruments of torture. It is very important that we keep such influences separate from scientific debate. The time for politics is after the science, not before or within the science. Very crucial. Let's look at food security, ensuring the world is properly fed. This has already been greatly helped by science. The Green Revolution increased agricultural production in the 1960s through high-yielding cereals, better irrigation, use of artificial fertilizers, pesticides, and so on. Developments led by the scientist Norman Borlaug, who got the Nobel Peace Prize now some years ago. The Green Revolution is often credited with saving the lives of over 1 billion people worldwide from starvation. However, and we should remember this, at the time, some environmentalists did not support these initiatives at all, leading Borlaug to say, and I quote, "Some of the environmental lobbyists of the Western nations are the salt of the earth, but some of them are elitists. They'd never experienced the physical sensation of hunger. They do their lobbying from comfortable office suites in Washington or in Brussels. If they lived just 1 month amid the misery of the developing world, as I have for 50 years, they'd be crying out for tractors and fertilizer and irrigation channels and be outraged that fashionable elitists back home were trying to deny them these things." That's what Borlaug said about the Green Revolution. But science is once again required to improve yields, to make agriculture more sustainable, to extend the range of crops to ecologically more marginal land. This can be helped through improving the growth of crops, assisting plant breeding, and by the genetic modification of plants to generate crops of higher productivity, reducing pesticide use to protect the environment and also biodiversity. We need to consider what science has to say about GMOs, about its risks and benefits, uncoloured by commercial interests and also by ideological opinions. It is not acceptable if we deny the world's poorest access to ways that could help their food security, if that denial is based on fashion and ill-informed opinion rather than good science. Another great challenge for the world is climate change. Discussions in this area impinge on politics, commercial interests, and very strongly held opinions. And these influences have distorted the scientific debate. Solutions needed to counter global warming are likely to require more concerted world action, regulating the activities of the individual, of industry, even of the nation state. And such restrictions are an anathema to some with particular political and economic viewpoints. Equally, those of an opposite viewpoint may exaggerate the extent of future global warming because of their affinities towards greater regulation and world government. This leads to some polemicists to confuse the debate once again by mixing up the science with the politics. The answer here is to focus on transparency, good debate, and good science. There is no room for preconceived ideas. First we need the science, then the politics. But unfortunately, there are some, driven by their political or ideological opinions, that mix these up. Often newspaper columnists or groups lobbying for particular outcomes, not always revealing, incidentally, where their funding comes from and for whom they may be lobbying. Now I want to turn to an issue that preoccupies most nations, that is, our economies. The Industrial Revolution brought scientists, engineers, technologists and entrepreneurs together to apply science to industry and the economy. The result was the steam engine providing power, chemistry and geology improving ceramics and the use of natural resources, mechanics and engineering constructing machines for transport and manufacture. This era is symbolised by the Lunar Society, a group of British intellectuals including James Watt, Erasmus Darwin, that's Charles's grandfather, by the way, Matthew Boulton. Erasmus was a very interesting man, in some ways much more interesting than Charles. Just one comment about him: he was a poet, a scientist, and rather fat. And he had a dining table made where he cut out an oval so he could sit closer to his food. Really interesting man. Erasmus Darwin, who else there? Watt, Matthew Boulton, Josiah Wedgwood. They discuss science and how science leads to new technologies and inventions to support the economy. They met together in the Midlands, in the middle of England, once a month under the full moon, that's why they were called the Lunar Society, to illuminate them during their ride home after dinner, I suspect after probably too much wine. Where would our economy be today without electricity, electromagnetism, electronics, synthetic chemistry, atomic physics, biochemistry, molecular biology, pharmacology? It would be very different. Some say that Michael Faraday answered the Prime Minister of his day when asked what good his inventions of the electric transformer, generator and motor might be, by saying, "Why, Prime Minister, someday you can tax it." It's probable that Faraday never really said that, but the anecdote captures the view of some politicians and business leaders who do not always grasp how science can enhance industrial capabilities and create wealth. So how can we make sure that science thrives and continues to bring benefits to our economy? I strongly argue that the first requirement is to have a high-quality science base. So how can that be achieved? Good science has a tradition of respect for empiricism, reliable observation and experiment, as I've said, and most importantly, needs to be carried out in a culture of openness and freedom without boundaries. The scientific endeavour is at its most successful when creativity is encouraged and there is freedom of thought. Scientists need to be able to express doubts, to be sceptical about established orthodoxy, and incidentally, particularly sceptical about their own ideas, which is more difficult, and they must not be too strongly directed from the top, as that stifles creativity. During the Cold War, Russia was able to build a nuclear bomb and to send the first man to space. Two great achievements, but mostly based on previously known physics. But work requiring new science was rather less fortunate in the Soviet Union. For example, genetics and crop improvement were completely disrupted because, for ideological reasons, Stalin-backed Lysenko, who rejected Mendelian genetics, accepted everywhere else in the world. Similarly, in Nazi Germany, Hitler rejected the work of Einstein because it was Jewish physics. Science does not thrive, ultimately, in such societies. For science to flourish, a broad portfolio of research investment is required. There's a continuum of research, ranging from discovery science, through research aimed at translating knowledge for application, onto subsequent innovation and the development of new applications and new technologies. The temptation to invest too heavily in a particular part of this spectrum should be resisted. Sometimes it's argued that we should concentrate only on translation and not on discovery. But that is a mistake. As Sir George Porter, Nobel laureate and president in the past of the Royal Society, said, to feed applied science by starving basic science is like economizing on the foundations of a building so that it may be built higher. It is only a matter of time before the whole edifice collapses. Research often needs a longer timescale than is usual, with the more short-term priorities of private business or, for that matter, of politicians elected on short-term cycles. And this can cause problems with longer-term projects required for translating scientific advances into useful applications. Bridging the often short-term pressures from commerce and politicians with the longer times required to develop discovery research into effective applications is crucial. Perhaps greater collaboration between publicly funded research and private companies can help move science to application by spreading the risk, by allowing longer-term views in private companies. Given the importance of science in our lives, how can we make the best decisions about what research should be supported? What are the factors that have to be considered when making these decisions? The one I think is crucial is the scientist who is carrying out that research, the person. Major discoveries in science are usually associated with highly talented individuals, and they combine a number of qualities: in-depth knowledge, creativity, understanding the values of science, how it's done, be well motivated, be effective. In-depth knowledge of an area of science is essential, but it needs to be combined with peripheral vision. If you're too narrow, you lose the sight of where you are. Carrying out good research is a creative activity, and scientists have more similarities than might be imagined with those pursuing other creative activities such as the arts, writing, and the media. Scientists thrive on freedom. Organising them is like herding cats. I know that because I've been trying to herd them for the last 25 years. Freedom of thought. Back to this. To pursue a line of investigation, wherever it may lead, to uncover, if necessary, uncomfortable truths, are all crucial to an effective scientific endeavour. A scientist whose thoughts are restrained or who is too strongly directed will not be an effective scientist. Scientists need to have respect for reliable data, a sceptical approach, particularly for their own ideas, an abhorrence of falsification or cherry-picking of data. And they also need to be highly motivated. Often this motivation is provided by a passionate curiosity about the natural world, a desire to know how things work or how they can be directed to achieve particular outcomes. But other motivations can also be important. A desire to undertake public good through eradication of disease, for example, to make something useful, to create economic wealth, or even perhaps to become famous. I don't recommend that because mostly we don't, of course. But whatever the motivation, it needs to be strong, because the pursuit of research is long and difficult. We shouldn't imagine it's easy. It is not. It is difficult. So given this emphasis I'm giving on the primacy of in the individuals carrying out research, decisions should be guided by the effectiveness of the researchers making a particular research proposal rather than the particular project itself. So, and the most useful criterion for this is immediate past progress. Those that have recently carried out high-quality research are most likely to continue to do so. So, in coming to research funding decisions, the objective is not to simply support those that write good quality grant proposals, but those that will actually carry out good quality research. Very critical. So attention needs to be given to actual performance. Now, obviously, such an emphasis needs to be tempered for those who have only a limited recent past record, early career researchers or those who have had a break in their careers. In these cases, I found it's very useful to have face-to-face interviews to determine the quality of the researcher making the application. So making good decisions requires a focus on the quality, passion and performance of the scientist wanting to carry out that research. Now, a perennially vexing question is how prescriptive should research funding agencies be in determining what research areas should be supported? It's a difficult question. It's a recurring issue because of the tensions between scientists wanting the freedom to decide what projects they should pursue and society, which supports science not simply as a cultural activity, increasing knowledge, but also as an activity aimed at improving the lot of humankind through achieving specific objectives. So how can this difficult tension be resolved? Well, it's not easy, but I'm going to make some observations. And in my opinion, there are three issues that are relevant. The first is what we call in Britain the Haldane Principle. Viscount Haldane wrote a review of research in Britain, I think it was published in 1917. And there's a principle often referred to from that publication, although actually it's not described as a principle at all in that particular publication. The second is a different approach when considering programs aimed at achieving applications and specific goals, and the third is a more imaginative role for scientific leadership in influencing funding, and I want to consider all three of those. First, the Haldane Principle. Today, 100 years after it was first stated, it's usually interpreted as meaning that researchers and not politicians should decide which specific research project should be supported. In a sense, it's a truism. Those that are expert in an area should be more involved in making decisions about that area when it is technocratic. Politicians, informed by external advice, should decide on the overall science budget and with identifying key priorities such as specific challenges or key infrastructures, but should not be involved in decisions on specific proposals which should be made by specialist reviewers with knowledge of the particular field. I think this view can be extended usefully more generally. Those leading research funding bodies should also focus their attention probably more on higher level priorities, avoiding the temptation to become too granular, too prescriptive, and finely grained in recommendations concerning what areas should be funded. Sometimes they want to pursue their own particular hobby horses, and that isn't always so useful. The point I'm making here can perhaps be illustrated by a metaphor derived from geographical exploration. In the 19th century, the Royal Geographical Society based in London might decide that it wants to support an expedition. It could be to explore the interior of Australia, the source of the Nile, or the Antarctic. But that society would be ill-advised to be too fine-grained in its deliberations and specify which creek in the Australian outback or African lake or South Polar glacier should be the focus of attention. That should be left to the explorer on the ground and not the committee in London. The funder's role should be to define the general geographical region of interest, identify the best explorer, properly equip that explorer so they can be most effective in the field. And research funders should behave in much the same way. They should put their trust in the explorer scientists carrying out the research rather than the committee in London. However, This approach needs modification when a research program is directed at achieving specific goals or applications, because that does require a more prescriptive behaviour. And sometimes by mixing all these things up, we actually get confused and misdirected. Goal-directed research can occur anywhere in the scientific spectrum. Whole genome sequencing would be an example at discovery end of research. It has to be directed in some way, otherwise everybody will sequence the same part of the genome. So there needs to be top-down direction. But it does tend to be more prevalent when thinking about translation and thinking about applications. Now, it's necessary and valuable to identify sectors which are close to application as being areas that are worth supporting. And this more prescriptive approach applies to research close to application, both for-profit activity driving the economy and not-for-profit activity such as improving the health and protecting the environment. I think what I'm trying to say here is just let's get real. It isn't quite the same across the entire spectrum. When you're close to application, you have to use different sorts of criteria, including what the research may be used for. If you're far away from that, don't assume you have to use the same criteria. And sometimes the tensions and arguments that scientists can even have between themselves are because they mix these things up. And it's really relatively straightforward. A third issue concerns the role of scientific leadership. If after getting good advice, a research funding leader decides that a particular research area is important and should receive more support, often the temptation is to ring-fence resources. And it may be more useful to undertake a process of education and inspiration of researchers so they become motivated to work in that area. Research leaders do need to be proactive, but micromanagement of the research agenda may not be the best way. Education and inspiration is also part of that mix. One reason for this is, of course, if you identify an area for something that you want to see supported and you don't focus on the individuals, then the risk is that you just attract people who are just following the money. And if you've decided you're going to spend 100 million Canadian dollars on something, you will spend it on the best you can find, but it may not be the best use of that money. So these are things that one needs to think about. Are there other special features concerning decision-making with respect to science close to application? Well, science across this whole continuum shares many similarities. Includes the importance of supporting talented individuals with the ability and passion to get the job done. But work closer to application is more likely to be multidisciplinary, may well require greater teamwork, not only covering the scientific disciplines, but activities outside science, finance, market analysis, and the law, for example. And it requires great effort to get individuals from such diverse backgrounds to work well together. And attention needs to be paid to encouraging mutual respect and to breaking down the boundaries that separate them. This would be encouraged if there was more permeability between the sectors, encouraging transfer of both ideas and of people. And we need to reduce those boundaries. We have too many barriers in place which lead to suspicion, which can block the interactions between the very people that need to be working together. One of the problems we have today is that increasing knowledge has led to specialization, making interactions between different scientists, industry, and the public services and other professions more difficult. It would be good if we could return to the simpler society of the lunar society, which allowed these interactions to occur more straightforwardly. Much is spoken about the valley of death. That is the gap between the generation of new knowledge and the application of that new knowledge, particularly for applications and commercialization. Usually when it's discussed, the focus of the discussion is on providing research support to bridge that gap. But another way of thinking about it is to pay attention to pushing, to use the metaphor, to pushing the bridgeheads further out into the valley before you try to cross that valley. There can be a problem when attempts to translate are made too prematurely before the knowledge is sufficiently reliable and complete. And this is particularly the case in the biosciences. To rush into translation runs the risk of becoming lost in translation. A firmer bridgehead needs to be built involving more extended and secure knowledge in the area of interest. Similarly, the bridgehead on the other side needs to be extended out, with investment from industry in research aimed at capturing new knowledge from the other side of the valley. And we need to think more about that simply than dumping money in the middle. Because without research capacity and knowledge in industry, it's difficult to build back over that valley of death. I want to put some of these ideas into practice at the new Francis Crick Institute being built in London next to St Pancras Station, of which I'm the director. It will open next year and have 1,500 scientists and will be, I think, the biggest biomedical laboratory, single building in the world. I want it not to be just a place for scientific experiments, but also a place for experimenting in the way that science is done. I want to create a sort of cultural and economic hothouse of scientific ideas and applications to make exciting discoveries which eventually can improve our health and drive our economy. And this means I do not want our scientists to spend all their time in the labs. They should spend a lot of time there, but not all their time. I want them to mix with the best minds from industry, the city, the public services, the healthcare delivery services, the media, to spark off new ideas to help science benefit us all. I want it to be a place without departments or hierarchies, with scientists free to pursue their own creative ideas, a science without boundaries. If it sounds a bit like anarchy, that is because it will be a bit like anarchy. It is often in mixed up and chaotic circumstances that the most creative work is done. Do you remember Harry Lime in The Third Man? What he said? In Italy, for 30 years under the Borgias, they had warfare, terror, murder and bloodshed. But they produced Michelangelo, Leonardo da Vinci and the Renaissance. In Switzerland, they had brotherly love. They had 500 years of democracy and peace. And what did that produce? The cuckoo clock. Very unfair on the Swiss, and in fact the cuckoo clock was invented in Germany, if I remember correctly. But anyway, if we want science to deliver all of this that I've spoken about, we must have a vision to succeed. We have to promote the highest quality creative and discovery research. We have to effectively capture those discoveries when they can be used for societal good. And if we get this right, our whole society will benefit. It is, in my view, a time for a new deal between science and society, a new enlightenment, perhaps, to achieve all of these things. And to do this, we need to encourage, cherish and promote creative discovery research for the benefit of humankind. Thank you very much.
Thank you, Dr. Nurse. In a moment, I'll invite Rosie Goldstein from McGill to more formally thank Dr. Nurse. But first, I'd like to invite Henry Friesen to the stage for some reflections on what he's just heard. Henry Friesen.
Thank you very much, Paul, for that tour de force in which you have reminded us that indeed science influences our lives in all aspects of our lives. It is a calling, it's an honor, it's based on honesty and integrity, and your thoughtful analysis and deeply penetrating dissection of the conduct and the quality and the conduct of science really has inspired us in ways that perhaps we hadn't appreciated before we arrived here. You will have gathered, as I have, that Paul Nurse is a man of powerful intellect, insatiable curiosity, boundless quest for understanding, with extremely broad interest in the role and place of science. Paul Nurse is not a man of small vision. He's a man of grand vision with big and bold ideas and pursues these with passion and persuasiveness and elegance and eloquence. I'm reminded of that actually when a few years ago Paul Nurse was invited to be the after-dinner speaker or the speaker at the Gardner Gala celebration. And just as you heard him today, but in a more abbreviated fashion, gave a wonderfully interesting, exciting talk that was extremely well received, and he was to be followed then by then Industry Minister Jim Prentice, who remarked after this positioning that he will never, ever again allow himself to be placed immediately after a Nobel Prize winner's presentation. The contrast was striking. Paul, you've inspired us to dream more, to learn more, to do more, and ultimately to become more. I think that was the challenge that I heard, that as we transform our dreams into reality, we have an obligation, all of us, to our society, to communicate effectively, to remind ourselves that science and research has an objective, and ultimately in the health field, that objective is to improve the health of individuals in our communities and around the world. Coming back to Ottawa after many years, I might say more regularly because of the prize, it reminds me yet again of the wonderful time I spent here, and most particularly of the period just around 98 to 2000 when Minister Rock, who was my minister, spearheaded and championed the creation of CIHR, and all of us owe to him and the government of which he was a part an enormous debt of gratitude. It is and remains, in my view, the golden era of science research funding in this country from 95-6 till 2003 when, led by Prime Minister Crick, government invested massive amounts, and today we are still the beneficiaries of those marvelous investments. I thank Abby Angel and friends of CIHR for honoring me in this way. I'm deeply moved by your generosity of spirit and your kindness, and to Paul Kennedy for broadcasting these lectures as he has over all these years. Thank you all.